So here, when you have got current circuit, the question says state Ohm's law. Here you have to use this is a simplified way of defining Ohm's law. This is a voltage, current, resistance. Okay, so Ohm's law states that the current passing through the conductor is directly proportional to voltage but inversely proportional to resistance, provided the temperature remain what? Constant. Temperature and other conditions, So what are the factors? The second question said, what are the factors affecting the resistance of the resistor? The temperature. The higher the temperature, the higher the resistance. Okay, the distance, the longer the resistors, the higher the resistance. The larger the resistors, the higher the resistance. Okay, also the ammeter is another factor. And then we have this diagram. I'm sure you're having the questions. Okay, so it is saying copy the circuit below and draw a voltage to measure the potential difference across the first 10 ohms resistor and ammeter to measure current. Okay, we are going to draw. Okay, so this is formats. So we are going to press ammeter for the first, for the first resistor, but you don't have to press it anyhow. The resistor, the ammeter is connected in parallel, so we are going to make sure that it is in parallel to the first resistor. And the ammeter should be in series, so we are going to put it in series like this. Okay, so it will look like this. Okay, like that. This is how it is going to look like. You see, this is the voltmeter, this is the ammeter. This is how it is supposed to be connected. This one should be in series with the resistor, but the voltmeter should be in parallel. Okay, remember we're dealing with this resistor here. Okay, and the resistance is 10 ohms. Okay, so here it is 6 kilovolts. So calculate the current through ammeter. Okay, so here we have been taught to calculate the current through the ammeter. So we have to know now the voltage, the voltage here and voltage there. We use this formula. Okay, voltage at 1 will be equal to total voltage, and then the resistor 1, and then resistor total. So total voltage is 6000 kV. 6 kilovolts is 6000 kV. Is 6000 volts. Kilo means 1000. Okay, that's what I've converted here. So V1 will be, if you calculate, and then once everything is done, we're going to get 3000 volts. Okay, this is V1. Okay, the V1. Okay, now we are looking for the ammeter reading, so we're going to apply voltage is current is voltage over resistance. So the voltage we have gotten is this one. Okay, so it is 3000 over 10. The way we got total, it is just adding this plus that. Okay, this resistor and that resistor. Okay, this is 10. Okay, and then that resistor 1 is just 10, and then 10 plus 10, 20. This 10 and that 10. Okay, so that resistor there, it is 10, and then the current, so it is what? 300 ampere. That's how we got this one. Okay, so that's how you solve it. The other question is what? Calculate the potential difference across 6 ohms resistor if it replaces 10 ohm resistor. Okay, potential difference is voltage. Okay, don't get confused. Potential difference across 6 ohms. So if we remove this 10, we put 6. Okay, how are we going to get it? Okay, it is going to look like this. Okay, we have removed that 10, we have put 6. So we are going to get the potential difference, which is voltage, is equal to voltage total resistance. So 6,000 is the what? Voltage total. So 6 here, and then we have got what? We have got 16, which is the total resistance, which is 6 plus 10 ohms. So we're going to have 2,250 volts out of what? 6,000. Okay, so it's going to be 2,200 volts. Okay, so that's how we find it. The other question is what? If one 10 ohm resistor is replaced with 2 4 ohm resistor in parallel, okay, if one ohm resistor, which is this one, is replaced with 2 4 ohms resistor in parallel, determine ammeter reading. Okay, so this one we are going to make it in parallel, okay, which is going to look like this. Okay, parallel. Okay, so let's calculate. Okay, let's calculate. So we have to first of all make sure that we break down this. Okay, so it is going to be 1 over R1 plus 1 over R2. Remember, it is different from capacitor. Capacitor, we could have just added this plus this, but here it is the opposite way, because this is a resistor circuit. So in parallel, 1 over R1, 1 over R2 raised to the power negative 1 is an inverse. So this is 4, this is 4, so 1 over 4, 1 over 4, we are going to get 2 ohms, because the inverse. So 4 will go on top, 2 will go down, so resistor is what? 2 ohms. Okay, so which is going to look like this. From there it is going to look like this. They are going to be in what? Series. Okay, so from there we apply the formula: voltage is current times resistance. Okay, so voltage total, we have to know the voltage. So voltage total, R1 and that. So voltage is 6,000. Okay, the resistor at 1, for which we are going to find the ammeter reading, it is going to be 2, and then the total is 2 plus 10. 2 plus 10, which is 12. Okay, so V1 is 1000 volts. Okay, now let's find the ammeter reading. Ammeter measures current. Okay, voltage is current times resistance, so current is voltage over resistance, and then we have got voltage is 1000, and then 2 is what? Our resistance. Okay, which is current is going to give us 500 ampere. Or the other way is to find the what? The equivalent resistance between these two. This plus that, we know that the current in series is just the same. So if this is 500 ampere, even this one, okay, that's why we can prove using this. Okay, like that. It is one and the same. So that's how you find it. You get the 4 marks like that.